Good evening. Namaste. How are you? Can you hear me? Your voice not coming. Okay. So we are going to do chapter 2. We started already. This is not for the first time. We started chapter 2, right? Is matter around us pure? Is matter around us pure? We already have done these things: pure substance, mixture, types of mixture, homogeneous, heterogeneous solution, a homogeneous mixture, components of a solution, properties of solutions, suspension, a heterogeneous mixture, collide, a heterogeneous mixture with smaller particles. Right? We have done these things. Okay. Now let us move forward to have the differences between homogeneous and heterogeneous mixture. What are the differences? Homogeneous and heterogeneous. Composition is uniform. The first difference, composition is uniform. When there is a homogeneous mixture, it is completely mixed. Composition is uniform. In this one, composition is non-uniform, means some particles are looking bigger, some particles smaller, some are looking, they are visible separately. Non-uniform. Number 2, particles invisible by naked eyes. These particles can't be seen with naked eyes in homogeneous, but in heterogeneous they are visible. Number 3, particles are small in homogeneous. These are very large. That's why they are visible. Cannot be separated by filtration. You cannot filter it. If you have a filtration system like a strainer, you pour the substance, whatever you have, homogeneous mixture, you pour it, everything will come out. Nothing will be filtered. It cannot be separated by filtration process. But it can be filtered. They can be filtered. Their components can be separated. Constituents have same physical properties. Number 5, constituents have same physical properties. But in this one, constituents have different physical properties. See the example, salt and sugar, they have similar physical properties. Both of them dissolve completely in water. Physical properties are same, like shape, size, hardness, right? They are all same. In this one they are not same. Like grains with pulses, you have suppose lentil pulse, mix some rice with it, they will be completely, their shape and size are different, they will be visible. This is rice, this is pulse, completely visible. Salt plus sugar, without water, salt and sugar, their size and shapes are different. So physical properties are completely different. These are the differences between homogeneous and heterogeneous mixtures. Next is about Tyndall effect. You might have seen this type of situation whenever you might be, you might have gone to a park to visit. Have you seen this canopy?
Yes. Yes, sir.
When you are standing under a tree, through the canopy, I mean through the gap of the leaves in the tree, some sunlight if coming down, you will notice that all the particles in air, I mean dust particles or whatever there is, will be visible in the path. Path becomes visible. That is Tyndall effect. Here see, there are two containers containing some liquids, some solutions. In the first one, solution of copper sulfate does not show Tyndall effect. See, the light source, light is coming, but light is passing through, but this is not visible. But here in the second one, you can see the path is visible here. I hope you are able to see this lining, right? And you might be noticing one more thing here, that the light source started with a very small circular part, but when it is advancing ahead, the circle is becoming bigger and bigger. So it is a scattering, becoming very bigger and bigger. Path is visible, that is one thing, and it is becoming bigger and bigger. Circular area becomes bigger. So copper sulfate solution is not showing Tyndall effect, but mixture of water and milk showing Tyndall effect. So what exactly is the Tyndall effect? How we can define it? Scattering of beam of light by the particles of medium is known as Tyndall effect. Now that medium can be a colloid or can be a suspension. We'll talk about colloid and suspension later also. Earlier also we have discussed, I guess, colloid and suspension. Suspension doesn't show Tyndall effect always, but colloid always show Tyndall effect. Suspension shows Tyndall effect sometimes and sometimes not. Next we are going to discuss about difference between suspension and colloid. Suspension and colloid. We already have discussed about it earlier. One more time. Suspension. Particles settle down. When you have a suspension in a glass, you leave it undisturbed for some time, maybe hours or maybe minutes, depends. The particles settle down in the bottom in the suspension, but in colloid, particles don't settle. You leave it for hours, days, that will remain same. Particles will not settle in the bottom. Did you understand settling down in the bottom?
Yes, sir.
Number 2, suspension can be separated by filtration. The components can be separated by filtration. Cannot be separated by filtration because of smaller particles. This may show Tyndall effect or remain opaque. I mean, it's not guaranteed that suspension will always show Tyndall effect. Sometimes may show, sometimes may not. But it will always show Tyndall effect. Colloid will always show Tyndall effect. Suspension, particles can be seen with naked eyes. These are bigger particles, but in colloid particles are smaller, cannot be it's not visible with the naked eyes, cannot be seen with naked eyes. Particles are very small in it, but remember both of them are heterogeneous mixture. We have talked about it. Both of them are heterogeneous mixture. Diluted and concentrated solutions, what are these? Diluted and concentrated solutions. Actually these two are comparative words. Comparative words. If only one thing is available, we cannot make a decision whether it is diluted or concentrated. If we want to make a decision whether something is diluted or something is concentrated, both of the two things should be available. Two things, because it is comparative words. See, someone says I am strong. What does that mean? Someone says I am strong. What is the meaning? Meaning is that the person is comparing with someone or with a group of people. Then he finds himself strong, right? If no one is there to compare, how can I say I am strong? If I say I am good, that means I am comparing myself with someone. Then I say I am good. I am comparing with someone or with some group of people. Then only I can say I am good or I am bad. I am sad or I am happy. If someone is alone, how can he say I am good or bad? How can he say he is sad or happy, strong or weak? These are comparative words. If alone, single thing is there, you cannot say anything about it. If two or more things are there, then only you can compare and make this type of statements. So, if amount of water in a solution is more, then you say it is diluted, and amount of water is lesser than that, then you say it is concentrated. Consider two solutions. Suppose you have two different solutions in two different containers. One of them contain more water, another contain lesser amount of water. Then you can say the first one is diluted because it has more water. The second one is concentrated because of having lesser amount of water. So diluted and concentrated are depending on situations. These are comparative words. Now I guess we have done it, so I kept it under recap portion. Concentration of a solution. Concentration of a solution. Actually, it is suggested in the book, in our NCERT book, that concentration can be found in various methods. There are various methods. But in our syllabus, only two methods are suggested. We have to take care of only two methods. First type is mass by mass percent. Mass by mass percent. The second one is mass by volume percent. Mass by volume percent. When it is mass by mass percent, then amount of solute divided by amount of solution is taken. But when it is a mass by volume percent, amount of solute divided by amount of one moment, it should be volume here. Let me check, I mistyped it. Yes, it should be volume here because we are comparing it with volume. That's typing error. Mass by volume percent means we take the amount, that means mass in the numerator and volume in the denominator. Here amount means mass. Amount means mass. Is that okay? yes, because of percent we have to multiply with 100 as well. So this is how we can find out concentration of a solution. If question is not giving, I mean, suppose question is providing us mass only, not volume, then of course question wants us to apply this method. If question is supplying the data with masses only, not with the volume, then question wants us to apply the first method. But if the volume is given, then maybe question wants us to apply the second method. Mass and volume both are given, then it is our choice, or maybe question wants us to find both of them. So it depends on the situation. Okay, no need to be puzzled about that. Now see, we have a question here. This is from NCERT. To make a saturated solution 36 gram of sodium, see the mass is given here, gram, mass. Sodium chloride is dissolved in 100 gram of water, again 100 gram, that is mass, at 293 Kelvin. Find concentration of this temperature at this temperature. So what do you think which method we have to apply with? Right, mass by mass percent. So either we will write this heading, mass by mass percent, or just write concentration of a solution, that will be okay. Concentration of the solution. We have to take mass of solute, mass of solute in the numerator, divide by mass of solution, the whole thing, in the denominator, multiply with 100. Mass of solute is 36 gram, and mass of solution, solute plus, yes, solute plus solvent gives solution. So it's 136 gram. Now multiply with 100 and you will get the answer. Gram cancels with gram, and let us see how many times we can cancel it with. 36 divided by 136. How much is it?
26.
Okay. 0.26, right? 0.2647 approx into 100, 26.47%, right?
Yes, sir.
Now there are various techniques of separating the components of a mixture. Give me a moment, I need water.
This is also free.
Okay. So now in the syllabus we have some techniques for separating the components of a mixture. Names are here: evaporation, centrifugation, separating funnel, sublimation, chromatography, distillation, fractional distillation. They are different. Distillation and fractional distillation are different. Crystallization and other methods, other physical methods like hand picking, sieving, filtration, etc. Hand picking, when we can do it? When the things are in a small quantity and in larger size, so that we can pick it by hand. For example, I saw one day what happened with my mom. There was a container with sugar in it. Some gram pulse just fell into it and mixed with sugar. And now mom has to separate pulse from sugar. Since it was very small quantity and the sizes were very differentiable, sugar crystals were very smaller, pulses were bigger in size, so it was possible to hand pick one by one, one by one. So in a few minutes it was done. Hand picking is also possible in some cases. Sieving, like you suppose cook tea, you boil tea with water. Do you consume tea? Do you consume tea? Yes.
No.
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 Okay. But you might have seen. Okay. But you might have seen your mom or dad or someone else doing this. Once it is boiled completely, the person has to separate the tea leaves, boiled tea leaves from the liquid. So what the person do? Person takes a strainer or a sieve, just pour it over. What happens? Liquid comes out and the tea leaves remains in that strainer, in that sieve. So sieving method also is suitable. Filtration. Filtration is somehow similar to sieving method. Filtration process actually is a bit different from sieving. Let us understand the two. Don't be confused between them. Filtration process is applicable for liquid mixture. Suppose you have some sand mixed with water and you have to separate the sand particles from the water. You can do filtration, not sieving. Sieving is used for solid mixture, like I said, sugar and pulse. So these are processes all somewhat similar. These two method works on the basis of difference in size. If sizes are same, then filtration or sieving will not work. These two work only because their sizes are different, like tea leaves and remaining liquid. Tea leaves are bigger in size, so it is easily strainable. We can strain it, sieve it. In the filtration also, sand particles are bigger than water particles, so due to the size difference this can be done. We also have to talk about these processes one by one. Let us talk about evaporation. Evaporation. You write with a pen. Pen has ink within it. How ink is made? Ink is a mixture of color and water. Color means dye. Dry color is dye. So dye is mixed with water to create ink. Now if you want to separate back that dye from the ink, what will you do? Evaporate, heat it up, water available in there will be evaporated, remaining things in the bottom will be ink. So evaporation works. In many other processes also evaporation can be used. Suppose accidentally you mixed some sugar into water and you want to separate that sugar from water. Just evaporate. With the evaporation process, water will come out and sugar will be in the bottom. But yes, if you expect to get the same size of crystals of the sugar, that may not be possible, but yes, you will be able to separate the sugar from that mixture. So evaporation is a process. Next is centrifugation. What is actually this? Centrifugation means, you might have seen okay, think of a process, washing machine. When you have washed some clothes and you want to dry it, there is a chamber in the washing machine known as dryer. You put those washed clothes into the dryer and you just switch it on. What happens? It rotates at high speed. And what happens? The heavier molecules just stick to the walls, right, and separate from the cloths. Does that happen? Have you seen it? You might have seen dryer drying clothes, but you might not have think how it works. That is centrifugation process. There is a force called centrifugal force. Centrifugal, something rotating all around but maintaining a center. Something which is rotating all around a point, is experiencing a force outside but doesn't go outside because of a thread or a string available there. For example, you have a stone piece, bind it with the piece of string. Suppose this is the string, this length of the string. You bind this stone and now you rotate. Keeping the other end of the thread, you rotate. What happens? Where you have hold it, that point is the center around which the stone is continuously revolving. What will happen if suddenly that string, thread breaks? The stone will go away from the center, right? That means stone was experiencing a force outwards that could take it away from the center. This force is known as centrifugal force. Actually, there are two forces, centripetal, centrifugal, that remains in balance. One force acts towards the center, other force acts away from the center. If both of them are in balance, then the stone remains moving round. But if one of them is absent, the other works. Well, that is not our discussion here. We just need to talk about centrifugation. What centrifugation is? We allow the things to rotate at high speed and the results are taken. For example, you have milk and you want to get cream from the milk. You might have seen some techniques in your kitchen as well. Have you seen this? Churning of milk? No? Wait. Advertisement. Village style curd churning. Curd or milk is taken inside a container like this, and see there is a stick bind with the ropes. Ropes are there because you want to rotate it. See, with the help of ropes, it is being rotated at high speed. This is called churning. Centrifugation also. This method is centrifugation also. Due to rotation of high speed at high, rotation at high speed, some cream is separated from the curd or milk. Cream is separated. This is the process, separation of cream from the milk or curd. This is how ghee, cream, butter, these things are separated. You might have noticed in the market we have various categories of milk, like toned, what is that? One is toned, other is double toned, full cream, toned, double toned. How these categories are made? These categories are made on the basis of amount of fat present in the milk. If the fat has not been separated from the milk, that is known as full cream milk. If some amount of fat has been removed, it is toned. Those people who have some cholesterol, heart problems, etc., don't prefer to have creamy milk. They prefer to have toned milk. And some people don't even want to have a small amount of cream. They go for double toned milk. Have you seen this? Yes or no?
Yes, sir.
Okay. So these separations are done on with the help of centrifugation. Drying the cloth in the dryer of a washing machine, separating cream from milk or butter from cream, these all things are done with the help of centrifugation. Next is separating funnel, to separate petrol from water. Once what happened with me, I had a motorbike. I don't know, that was a manufacturing defect, I guess, in the petrol tank. The bike was always kept outside. I didn't have a space to have it inside. In the rainy season, it was raining a lot, day and night. I don't know how, drop by drop, some water was leaking to inside and going inside to the inside the petrol tank. So petrol was being mixed with water with some amount. And do you know what happens when water is mixed with petrol? The structure is like this. Suppose this is the petrol tank of the bike. So in the bottom it has an outlet where petrol goes to the engine. Here is engine, suppose. Petrol goes to the engine to burn, but when water mixes with petrol, water has higher density than petrol. Suppose there is a container. You suppose have petrol and water mixed together in this container. What will happen? Water will be in the bottom. Water will be in the bottom because of being at higher density. Density of water is more than petrol. Petrol remains on the top of water because density of petrol is lesser than density of water. They never mix. So when in my petrol tank water came, rainwater came, water comes in bottom here. Water comes in the bottom because of higher density. Petrol goes up. And in that case, whenever I tried to kick start my bike was not starting because water was coming to the engine, not petrol. Now it was a big problem. I faced it, I remember many times. In the rainy season, I had to face this problem, in rainy season twice or thrice. Many other people I have seen face this problem. Later on, I just sold it. I was very fed up with this, so I sold it. Well, that is not a part of my story. I sold it or not. But the part is that what was the solution of this problem? Let us understand, because this is the part of our syllabus. How to separate this water from the petrol. So I just dragged my bike to the mechanic's shop. Mechanic removes the pipe that is connecting from the tank to the engine, removes it, and with the help of a separate pipe, he collects everything, all the mixture into a bottle, into a container. You can say a plastic bottle or any container. Mainly I saw him using plastic bottles that we use, that we have with water bottles or soft drink bottles. Those plastic bottles were used. So all the mixture got collected here. Once it is completely empty, once the tank is empty, now he just covered it with the cap of the bottle. It was airtight. Now what he does, he turns it down. When he turns it down, water comes in the bottom, and he slowly loose the cap so that water can come out. He allows it in a controlled manner so that petrol can be saved. Water can just come out. So all the water being in the bottom comes out slowly, and their colors are also different. Petrol is yellowish in color. Water is transparent, white. When water comes out, remaining petrol was put into the tank, and now I am ready to go. Kick start the bike and go. Have you seen this process? Have you heard of it ever? No? I faced it many a times. Well, this is a part of our syllabus. separating funnel. So in that case, funnel was like a bottle. Bottle was working like a funnel. Okay, next is sublimation. Suppose ammonium chloride is mixed with salt, and we have to separate ammonium chloride from the salt. What we can do? Ammonium chloride is a solid substance having very low boiling point. What happens when we give even small amount of heat? It evaporates easily, and without converting into liquid, directly from solid to gas conversion happens. Have you heard of it?
Is it like camphor?
Are you asking something?
Sir, is it like camphor?
Yes, camphor is the similar thing, but ammonium chloride is different. They both follow this process. They both are sublime metals, sublime solids. They can convert directly from solid to gas without changing into liquid. Okay, so that is sublimation process. Chromatography. Suppose a manufacturer wants to manufacture ink, whiteboard marker ink, pen ink, and he wants to copy an ink that is already existing. How he can copy? It is very difficult to copy a color. Once I was getting my house painted, what happened once, due to some confusion, the painters created certain color of paint to paint the one room and hall. When he came to the other room to paint, that paint was shortfall, that was no more available, so he had to prepare it more, but he forgot the composition, how much, which color was mixed together to create that particular paint, particular shade. He forgot. So he was trying it again and again. He made, I guess, 5 to 6 samples, and he was just putting over here and there to make a match. It was not matching. It is very difficult to mix and match to get the same color again. Very difficult. In that case, chromatography helps. With the help of chromatography, an expert can understand how much, which color to be mixed together to get the desired shade. When a person goes to get his car painted, repainted, it happens sometimes due to some accidents, paint damages, so the person may want to have it repaint. When he goes to repaint his car, it's a risk that the new color will not match with the older color. If he is getting the whole car painted, that's not a problem. But if he wants only one part of the car, like just the front part of the car, just the back part of the car to be painted, it's a problem. And the problem is that the new paint may not match with the old paint, and that will be looking odd. The person doesn't prefer it. So he searched for an expert painter. What does painter do? Painter takes a small sample from the part where the paint is safe and it is desired. He takes the paint, use chromatography to understand which color in what quantity, what amount was mixed to prepare this desired paint, and he is now ready to prepare the same shade of paint with no difference. He guarantees, the painter guarantees to his customer to have the same, exactly same match. How does this happen? Due to chromatography. Similarly, if a manufacturer wants to create the same ink, he will take the already existing sample, use chromatography to see what shades are available mixed together in what quantity, and he will mix the similar colors in the same quantity again and will get the same result, same ink with no difference. So chromatography is used to separate colors from ink. If you are using a black pen, it has black ink inside. So do you think black ink is a single color, single dye? No, actually not. Any color may not be single. Most of the time it is a mixture of two or more colors. We are using a pen that may be blue, black, red. Blue also is of a different shade. Sometimes it is a light black, dark black, light blue, dark blue, etc. So any color may be the mixture of two or more colors. If we want to separate all those constituent colors, we have to use chromatography. Next is distillation. Distillation is used, suppose consider two liquids which are mixed together and we have no other process to separate them, like acetone and water. Suppose we have a bottle of acetone, we are opening the cap to check something, accidentally it falls and the whole acetone goes into the water that was kept in the bottom in some container. It is now mixed. Now we want to separate that acetone from water. What we will do? We will do distillation. Distillation. What happens in it? Distillation is a process in which you take that mixture, acetone plus water mixture, take into a container. It may look like this. Suppose you have this container, acetone plus water. Acetone plus water. You need an arrangement. You take a pipe fitted with it like this, connected with another pipe. It is closed on the top. Here is a container, another container. Now this pipe is surrounded by some other material which is supplied with, which has empty space and which is supplied with cold water. Cold water. Now what happens? You heat up this mixture, you provide heat to this mixture. How much is depends on what type of mixture, what type of liquids do you have. You may get a thermometer here fitted in it, thermometer. What will this thermometer do? You are giving heat. Due to heating, one of these two will be evaporating first. Both of them are having different boiling process, boiling point I mean. What is boiling point? Do you know what is boiling point?
Which when a substance gets boiled.
Boiling point is a temperature at which something boils, starts boiling. So suppose you started supplying heat, acetone has lower boiling point than water. So at a lower temperature, acetone starts boiling, and after boiling, acetone starts becoming vapor. It evaporates, goes up. Temperature is fitted just to indicate how much temperature you have set. It will give you the idea how much temperature is being supplied, and you can control it. Okay, so acetone is now evaporating, going into this, flowing through this pipe, but due to availability of cold water all around the pipe, it is becoming condensed. Evaporation, condensation. Have you heard of these two processes? Evaporation means liquid converts into gas, and condensation means gas converts to liquid, like water. You heat up, water becomes vapor, means gas. Now that gas, when you cool it up, it converts into liquid back. So we have given heat, it evaporated, now we are cooling it, so it converts into liquid back, and by drop it falls here, it collects here. So the whole acetone can be separated this way from the water. You will not raise the temperature so that water can start boiling. You will supply only that temperature which will allow acetone to boil, not to water. So this method is known as distillation. Any questions? Got it? Okay, after distillation, it is a fractional distillation. Fractional distillation is used to separate gases from air. We already know air has a composition 78% nitrogen, 21% oxygen, 1% other gases like neon, argon, etc. So if we want to separate nitrogen or oxygen from air, we can use fractional distillation, which is almost similar to distillation, but due to some different arrangements, this has been named as fractional distillation. The last one is crystallization, to separate pure substance from, misprint 2 times, from its impure sample. Okay. Now I will show you some videos. Let us see dye from ink. How to separate dye from ink? The person has taken ink bottle. He is going to mix that ink with water. Some amount of water is there. Some droplets of ink is mixed with that. Now he will separate the ink from the water. He will use evaporation. So over the candle's flame, he will heat it up for some time and see what will happen. You can see the amount is getting smaller and smaller. See, a very less amount of water is remaining there, right? It is getting evaporated. And after some time, the whole water will be evaporated and only that dye, I mean the ink, will remain in the bottom, in the spoon. Done, finished. Only the ink is remaining there. Separation process. ऐड भी देखना पड़ेगा, देखना ही पड़ेगा. This is about separating funnel that I said about mixture of petrol and water, how to separate. Similarly, you can think of some other liquids as well. चलो इसके fittings नहीं देखनी हमें. We are not interested to see the fittings. Oil, water, oil and water mixed together, just like petrol and water. See, water in the bottom, oil on the top, they never mix. Now you want to separate, you will take a separating funnel and it will be separated. So this bottle is being used as the separating funnel. There is a keep over the cap fitted here. See, water came down because of higher density, oil on the top because of lower density. He is allowing water to come out. Water is coming only, not the oil. Oil is safe there. This layer of oil. This is called separating funnel method. Now water came out all, only the oil is remaining. Now he can stop here and done. The process is over. Now let us see chromatography. Chromatography, how colors are separated. Chromatography. There is an ink. I'll show you two videos on chromatography. This is first. I'll show you the another one as well. See, when the water touches the, this is paper stripe. When the it is wet with water, water spreads through that paper stripe, and when this is paper stripe having a small amount of that color on it, it is just hanging here, very small amount of water is in the bottom, paper stripe is touching the water here in the bottom, And you might have seen when you have a paper stripe like this, if one side, one end of the paper stripe is wet with water, water slowly spreads throughout the paper till the other end. Have you seen this process ever?
Yes, sir.
Yes, especially it happens fastly with tissue paper. If it is a tissue paper, it happens very fast. So what happens, as the water spreads, the color also spreads. And which property helps us to separate the color? Actually, all the color components. You might have seen, if you have not seen, you can do this experiment. You might be having color for some projects given by school. So sometimes if you have that color available, take red color and green color, dark green, dark red. Mix 1 drops of each together and see the result. What will happen? You have any guess? Any guess what will happen? They will create a black color. Black color. Green, red together mix with black color to form black color. I remember once I was playing Holi. One of my friend came with both of these colors. Actually, not one, 2 of them came. One was having green color, other was having red color. I was unknown about all these accidents going to happen. So one of them having green color, he just kept some powder over the hand, some droplets of water, mixed it here, green color, and suddenly came to just paint my face with green. The other one who was ready with the red color now came and painted it red. Finally, I was completely black. As a result, you will see, if you have some time, both of this color, especially liquid color, mix them up together and you will see the result will be black. Now from that black color, if you want to separate red and green, you can use this chromatography. Take a stripe of tissue paper, put a small droplet over the paper, let it dry, let it be dried, hang it in the same manner. You can see there is a stick here, a stick on the top, on the beaker. It has been rounded here so that it can hang inside. In the bottom, take very small amount of water so that only one end, small part of that stripe can be wet. Now water will start moving up through the stripe. Water will move and it will carry the colors as well. The water will carry the color as well.
Yes.
What happens actually, the color components like red and black, red and green, etc., whatever it is, these color components travel with water with different speeds. This is important, remember. Different color components travel with water at different speeds. Maybe, I'm not sure which one will travel faster, but maybe green will move faster, red will move slower. If it moves slower, then you will see the red color in the bottom and green on the top, because it is faster, it is moving fastly, so it will travel more than the red color. And this way you will be able to understand which colors were mixed together to form that resulting. Okay, let us see this now. It is rising. Can you notice? Is it visible to you? It's rising.
Yes, sir.
and notice the different colors, yellow in the bottom, reddish in the middle here, pink, reddish, etc., and purple on the top, different colors. So it is giving us the idea which colors were mixed together to form that resulting color. Now putting it over the scale, the person is trying to have the idea using some mathematical calculations how much distance was for yellow, how much distance is for pink, how much distance is for red, how much is for purple. Using that ratio over the scale, he can find out the percentage mixed. He can find what percent of yellow color, what percent of red, what percent of purple were together mixed, or purple or blue, whatever it is. It's not clear to me. Well, this was one video over chromatography. This is the process which is followed to prepare some specific paint shade. Chromatography is another video. In this video you will see chlorophyll. Chlorophyll is a green pigment, but see what are the mixtures available. Chlorophyll chromatography. The person has taken some green leaves, he is mashing it inside a mortar. He has prepared a paste of it. The green paste of the leaf. He is going to cut a paper stripe here. He will put a very small amount of that green paste over this paper. He has fixed the one end of the paper with the stick so that it can hang in the beaker. In the bottom there is very small amount of water. He is putting marking a line here. I mean, how much water should be put into the beaker. For that purpose he has marked it. See, small amount of that green color is given here. Now it will be hanging inside that beaker. Some water is there so that another end of the paper stripe can be wet. Now water spreads all around. He has just covered it with plastic so that no disturbance of air can be there. Now see, the green color is spreading. Some yellowish color in the bottom you can notice here. Upper part is the dark green color. So red pigments, I mean chlorophyll is going up. Chlorophyll is going up. This is a scientific experiment. Chromatography. Now let us see distillation process. A video over distillation. See, some mixture is there where two or more liquids are mixed together. Some temperature is being supplied, some heat is being supplied. How much temperature should be there? It can be controlled with the help of a thermometer. Now you can notice some one liquid of them is getting evaporated, coming here, and it is exit, and there is a cool water moving all around that pipe, but not going into that pipe, but cooling it. Purpose of this cold water flowing is to make this inner pipe cool, so that the liquid which was evaporated and got converted into gas is now condensed and being converted back into liquid, coming down to the other container, being collected there. This process can be used to have clean drinking water. Suppose we are in a forest and a camping where there is no clean water available to drink, but there is a river or there is a pond. We take that water, we put the mixture here, and we know 100 degrees C is the temperature, is the boiling point of water. So we have to supply 100 degrees C temperature here so that water can evaporate, only water. So water will evaporate, first convert into gas, then it will be cool to convert into liquid back. Into the another container we will have pure water. Pure, it is called distilled water. Distilled water is the purest form of water that can be drank. Any questions till now? Okay, that's it for today. I hope you enjoyed this science class. Okay, bye bye. See you in the next class.